Once upon a time, people saw only stars and the hazy Milky Way in the night sky. They found patterns in the stars. In summer, Sagittarius, the archer, looks like a teapot. In autumn, Pegasus the horse, with Andromeda and a small ghostly light by his hind legs. In winter, Orion the hunter and his big dog Canis Major chasing Taurus the bull, who has 7 little stars called the Pleiades, or 7 sisters, on his shoulder. In spring, Leo the lion and the Big and Little Dippers, or Big and Little Bears, were highest in the sky. But that was all there was. There wasn't any more. Then something happened. In the 1700s, while Americans were fighting for independence and Handel was composing his Hallelujah Chorus, Charles Messier, a French naval clerk, was using a small telescope to catalog over 100 smudges in the sky so they would not be confused with comets. He gave each a number. These may still be seen with a backyard telescope. M1, a crab by Taurus. M97, an owl in the Big Bear. And M82, a cigar. M57, the ring and lyra. And M27, a dumbbell. Some backyard telescopes are better than others. In the 1840s, Lord Rosse, with his telescope at Birr Castle in Ireland, was the first to see the spiral arms of the whirlpool in the Big Bear and sketched it to show friends. But that was all there was. There wasn't any more. Then something happened. Funds and technology became available to build bigger and better telescopes. Photography flourished. Faint light was captured not only by larger mirrors, but by longer exposures. Suddenly, all of Messier's objects were found to contain stars. M22, M55, M15 became clusters of stars sparkling like sugar around the teapot and under Pegasus' nose. Stars in clusters 12 billion years old danced around one another, held together by some strange force. Bright young blue stars danced with old yellow ones. Sometimes the clusters danced in pairs. The Pleiades, or 7 sisters, were dancing in 7 gossamer veils. Other stars illuminated thick clouds, such as in the Great Orion Nebula. Nearby, the Horsehead Nebula came into view. The huge Pale Rosette Nebula appeared. Gas and dust were being pulled together by a mysterious force, gravity. Stars were being born in tidy symmetric nebula like the owl, the ring, and the dumbbell. Telescopes revealed single stars in their centers. The stars were blowing off nebulous shells. The stars were dying, turning back into dust. One of the clouds was less tidy. M1, the Crab Nebula near Taurus, had 2 stars. There, in 1054, a giant star lit the daytime sky in a blazing explosion, a supernova. Outside the plane of the Milky Way, spiraling smudges also began to show stars. When John Herschel saw their shapes were similar to his father's diagram of the Milky Way, he pondered there must be other universes outside our own. Imagine had he lived to see what we see today. The smudge the ancients had seen in Andromeda, Messier's M31, became the Andromeda Galaxy. M51, Lord Ross's Whirlpool in the Big Dipper, became the Whirlpool Galaxy. Many other beautiful galaxies appeared, especially in spring. Above the Milky Way in the Big Bear, in Leo, and in the arms of Virgo. But that was all there was. There wasn't any more. Then something happened. At Mount Wilson, Edwin Hubble, a former basketball coach from Kentucky, and Milton Humison, who drove supplies by mule team up the mountain, worked together looking at photographic and spectral plates taken of galaxies. Characteristic patterns of dark and bright spectral lines revealed the composition of a light source. Hydrogen, iron, magnesium, sodium, calcium. Comparing photographic plates allowed them to detect changes in the heavens. Meanwhile, Henrietta Leavitt, a volunteer at the Harvard Observatory, searched the small Magellanic Cloud for unstable pulsing stars called Cepheid variables. She noticed the brighter ones changed more slowly. The faintest pulsed once a day, while those 100 times brighter pulsed once in 50 days. Hubble and Humison, searching the Andromeda Galaxy for novas that brightened once before dying, noticed one star continued to blink. It had the right spectrum for a Cepheid variable, but it seemed very faint for its pulse. It was far away. Hubble realized the Cepheids' brightnesses were so predictable he could estimate the distance of galaxies in which they were found. In examining spectra in distant galaxies, he noticed the further away the galaxy, the more the lines shifted toward longer infrared wavelengths. Hubble reasoned that just as the Doppler shift of passing sound sources, such as trains or automobiles, lengthened wavelengths and lowered pitch when they moved away, a receding light source shifted its color toward infrared, the red shift. The more distant the galaxy, the faster it was moving away. The universe was expanding. If so, what size was it billions of years earlier? What pushed or pulled it apart? A basketball coach and a mule driver had not only discovered the expanding universe, they were stumbling towards the Big Bang. But that was all there was. There wasn't any more.
Ignition. Liftoff. Liftoff. 30 minutes after the hour.
Then something happened. In the 1990s, a telescope was sent above the Earth's lights, weather, and atmosphere. A telescope that saw infrared and ultraviolet as well as visible light. A telescope that not only brought objects closer and clearer than ever before, but could allow us to travel to the edges of the universe, looking towards the beginning of time. The question became not where in the sky, but how remote in the universe. Now we could visit places no one had gone, to see things no one had seen. A journey we hope you are prepared to take now. To reach the moon, traveling near the speed of light takes a little over a second. To reach the nearest star would take 4 years. According to Einstein's theory of general relativity, to us, the trip would seem little more than an instant. Further on, we pass the dog star, Sirius. Its white dwarf companion has the mass of our Sun compacted smaller than the Earth. and gravity 400,000 times that of our own. So dense, a teaspoon would weigh as much as an elephant. On Taurus's shoulder, we see the beautiful Pleiades. The light we see left there when Galileo first pointed his telescope towards the heavens. And not much longer to reach the red giant, Betelgeuse. Brighter than 40,000 suns, spread wider than 2 Earth orbits, it has very little gravity toward its edges. In Orion's dagger, we see the Great Orion Nebula. Hubble's infrared cameras, able to see through blankets of dust, find the nearest star nursery to Earth. Over 16 light-years wide, the nebula cradles hundreds of fledgling stars and some brown dwarfs too small to fuse hydrogen. Seemingly floating nearby, the beautiful Horsehead is silhouetted against the magenta glow of ionized hydrogen gas. The light we see left the Horsehead around the time of Attila the Hun. Swinging towards Sagittarius, we pass more star-birth nebula. The Trifid Nebula, 2,200 light-years from Earth. Then the Eagle Nebula, 3 times further out. Hubble not only sees the beautiful glow of hydrogen, but using false color reveals traces of sulfur in red, oxygen in blue, and hydrogen in green, ready for gravity in the famous pillars to pull them together to create more new open clusters of beautiful stars found throughout the Milky Way. The center of the Milky Way, like steam from the teapot spout, is surrounded by a sphere of globular clusters of stars. M22 in Sagittarius to M15 in Pegasus are among the oldest objects in the universe. They were created nearly 12 billion years ago. Among the flocks of new and old stars are reminders of their ultimate fate. Dying stars, puffing out their last gasp, show what our sun may be like 5 billion years from now, collapsing to a white dwarf, smaller than Earth, within a beautiful nebulous cloud. Hubble sees details of the Dumbbell Nebula and others that remind us of Messier's ring and Lyra. Some puff off quiet, ghostly spheres. Others shoot out like firecrackers, sending out streams of the stuff of future stars. Then there are the giant stars that explode into magnificent supernovae, as bright as a whole galaxy, so brief and rare we may wait centuries to see one in our Milky Way. We watch and wait for Eta Carina, a giant star seen from the southern hemisphere, to explode in a supernova at any moment. 1,000 years after it exploded, the Crab Nebula's central star has collapsed to the size of a small city. Spinning at the rate of 30 times a second, stuttering radio waves, its brightness pulses as it streams out matter and antimatter near the speed of light. The hydrogen-rich universe had only a few heavier elements fused within stars, but with the sudden collapse of giant stars, shock waves squeezed surrounding matter to become all the elements we know, not only bits of diamonds and gold, but all the elements needed to make up life. A universe once of only hydrogen gas now contained wisps of supernovae floating through space, ready to create 3rd and 4th generation stars. Stars with solid planets, flowers, trees, all kinds of living things, where everything and everyone was once part of a supernova, where everything and everyone is made of stardust. Although the supernova amazed the Chinese and Native Americans, shining in the daylight for weeks in the summer of 1054 AD, it actually happened 6,300 years earlier. Compared to the sun's distance of 8 light minutes, to be visible in daylight, it would have given off light greater than 10 million suns. Visible only from the southern hemisphere are the large and small Magellanic Clouds. Our galaxy, 100,000 light-years across, is just 180,000 light-years from these. Light we see now left them when men were living in caves. Just as in the Milky Way galaxy, everything in these galaxies has to do with stars, star-birth nebulae, star clusters, and supernovas. Traveling onward, not thousands but millions of light years away, we see billions of beautiful galaxies. Some show bright blue star-birth nebulae and yellow areas of older stars. Some show rings of star-birth around their edges. Others show quiet star-birth near their central black hole. While supermassive black holes with enough gravity to hold together galaxies of billions of stars create bubbling cauldrons. The little cigar close up seems to warn us of the hazards of smoking. And starburst galaxies have millions of stars being created everywhere. More clusters of galaxies come into view. Some passing very close indeed until the inevitable happens. They collide. Collisions span millions of years, spawn new waves of starbirth, send plumes of dust out into space, and finally settle into new galactic shapes. We dread anything so cataclysmic should ever happen to our Milky Way, until looking back, we see something very strange indeed. We are living in a galaxy that is colliding. Then, something happened. The Hubble took longer exposures to catch even more distant traces of light. We could travel not millions, but billions of light years. A spot of sky the size of a dime 75 feet away held 1,500 galaxies, familiar, unfamiliar, strange, and unimaginable. Massive structures of galaxies, the weight of several thousand of our Milky Ways, were everywhere. Seyfert galaxies and powerful quasars, hundreds of times brighter than familiar galaxies, shooting off gas knots at wild velocities from angry, greedy, gobbling black holes. Areas of dense matter warp space, creating gravitational lenses, magnifying and distorting light from more remote galaxies. But even at this distance, we find bright supernovas, creating the materials of life. Others so massive they collapse to black holes, blast out gamma-ray bursts of powerful X-rays. Everywhere there is heat and sound, traces from the Big Bang. Everywhere there is hydrogen from the early universe. Looking back, after traveling 5 billion light years, if we could see our tiny galaxy and our minute sun and tinier Earth, we would see how the Earth was 5 billion years ago, a glowing molten ball Further than 5 billion light years, there would be no Earth, no sun, only dust and gas. Then something happened. Using Hubble's cameras to take exposures lasting a day or longer, catching fainter light in the ultra-deep field, we look towards the very edge of the universe. Light so old, it came from near the beginning of time. These distant galaxies are traveling away from us, nearing the speed of light. Visible light has shifted out of sight into the infrared, while what would have been ultraviolet light appears in the visible range. We are seeing light 13 billion years old, looking back in time 13 billion years to within 1.5 billion years of the beginning of time. Still, there are beautiful galaxies. But what of the universe further back in time? The universe is expanding. How much more has it expanded in 13 billion years? How far can we go without becoming lost forever? Will we ever witness the beginning of time? Hubble shows us the very edge of the Dark Age. We dare not go further, for fear our spacecraft, lost in the expanding universe, could never make it back or find refuge on any other planet exactly like ours, with the same size, the same chemical composition, with the same warm sun, trees and birds and flowers and friends. With the help of a gravitational field, we might swing about like a slingshot for our return trip. Traveling near the speed of light, the trip will seem instantaneous. Will the Earth be the same? Will our friends on Earth have aged 13 billion years in our absence? In a moment or two, crashing back wildly past enormous cauldrons of fire, we dodge the grip of giant black holes, pass through thick sulfurous clouds, traverse light years of near vacuum space, until finally, we're home. The Hubble Space Telescope has shown us the visible universe. That was all there was. There wasn't any more. Or was there?